All right, this is Module 3B, Review Answers. First one is from Lesson 8. Recall that an odd number is a number that is one more than or one less than twice an integer. And consider the sequence formed by the odd numbers 1, 3, 5, 7. Our job is to find a formula for the function of n, the nth odd number starting with n equals 1. So I would start by making a table just so you can see what's happening here. N is our input, the function of n is our output, and the first number in the sequence is a 1. The second number in the sequence is a 3. The third number is a 5, and so on. The fourth number is a 7, etc. Okay, and then if we look at this and we see that if our independent variable changes by 1, then the change in our dependent variable, which in this case is a plus 2, is our coefficient. So I can say that f of n is equal to, I know it starts with 2n, and then I'm just going to adjust. So if I say, well, what if n is a 1, then I plug a 1 in for n, and that's 2 times 1 is 2, but I want it to be a 1. So how do I make that happen? Well, I just subtract 1. All right, there's the first one. Number 2, write a convincing argument that 121 is an odd number. Well, I would say if you double any number, the answer is going to be even. And then if you add 1 or subtract 1, then you'll end up with an odd number, right? One bigger or one smaller. So, if you double 60, you get 120, and then add 1, it's odd, right? So if I double 61, I get 122, and then subtract 1, I get an odd number. So either way, whether I add 1 or subtract 1, I get the odd. I could also think of the columns of dots. 121 would be a column 60 dots high next to a column 61 dots high. It's going to make it an odd number. So a couple different ways you could answer that one. What is the meaning of f of 17? Well, that is the 17th term, in the sequence. All right, number 4. Given f as described below, where the domain is all whole numbers. So remember, this first part is the domain, the input, which will produce an output, that's the range. Assign each whole number to its largest place value digit. So, for example, in the first one, the largest digit is a 4, so that produces a 4. And in f of 14, the largest digit is a 4, so it produces a 4. In f of 194, the largest digit is a 9, so it produces a 9. And then the question is, what is the domain and range? Well, the domain is going to be all whole numbers. What they told us to begin with, all whole numbers is the input. And then the range is limited. It's limited by our function, and really it can only have a certain number of outputs, right? If I said what is f of 0, well, the largest digit then is a 0. So it could be as small as 0, and it could be as large as a 9, like we saw here. So the range is 0, 1, 2, 3, 4, comma, 5, 6, 7, 8, 9, and close that set. So the range is all of those integers from 0 to 9. What is f of 257? Well, the largest digit in that is a 7. So that would produce a 7. F of 999 would produce a 9. Find a value of x that makes the equation f of x equals 7 a true statement. Well, lots of opportunities here. As long as 7 is my largest digit, could be anything. 7's my biggest digit, so it's going to produce a 7. All right. Number 5, is the correspondence described below a function? Where we're saying that the input is all women and the output is people, specifically children. We're going to assign each woman her child. So let's say we had woman A. Woman A could produce child 1. Woman A could also produce child 2, child 3, etc. And since that is the case, it is not a function because every input can only have one specific output. So this situation would not be a function. Number 6, let f of x equal 4 times 3 to the x power. We're just going to find what the function of x would be and complete the table. So when x is -1, well, that's going to be f of -1 is equal to 4 times 3 to the -1. And then we have to remember that anything to the negative exponent is the reciprocal. So this is 4 times 1/3 to the positive 1. That's the only way we get a positive exponent. And that's just 1/3. So 4 times 1/3 is 4/3. So there's the first one. And then we're just going to keep plugging in different values of x into our function. So f of 0 is equal to, well, that's 4 times 3 to the 0 power. And 3 to the 0 power is 1. 1 times 4 is 4. Okay, let's put a 1 in there. F of 1 is equal to 4 times 3 to the first power. That's 3. And 3 times 4 is 12. And maybe you could see a pattern emerging. Looks like we're multiplying by 3 every time. We can just keep checking to be sure, right? So f of 2 is equal to 4 times 3 squared. 3 squared is 9. 9 times 4 is 36. Yeah, 12 times 3 is 36. 4 times 3 is 12. Looks like that's the case. F of 3 is equal to 4 times 3 to the third power. That's 27. And 27 times 4 is 108, which again is 3 times 36. All right, moving on. Number 7, Jenna knits scarves and then sells them on Etsy. Let C of x equal 4x plus 20. Represent the cost in dollars to produce 1 through 6 scarves. So our x values, let's make a table. X and C of x. Our x values are given to us, right? 1 through 6. So 1, 2, 3, 4, 5, and 6. And then we just plug in those x values to calculate the function of x. So let's do that over here. C of 1 is equal to 4 times 1 and then plus 20. Well, 4 times 1 is 4 plus 20, 24. So when x is 1, the function of x would be 24. C of 2 is equal to 4 times 2 plus 20. Well, that's 8 plus 20 is 28. Let's do one more because I sense a pattern, but let's make sure. 4 times 3 plus 20. Well, that's 12 plus 20, which is 32. And it looks like we're just adding 4 every time. So this is a 36. 5 is a 40, and 6 produces a 44. So there's our table. What are the domain and range? Well, I won't write it again, but you could just write it or just recognize that the domain is the x value, the input. So that's the domain. And then the range, let me get a new color here, maybe. That'll work. The range is the output, or c of x, the function of x. So domain, you could make, you could say the domain is, and then make yourself a set, and say it's 1, 2, 3, 4, 5, and 6, and do the same thing for range. I think you get the idea. Part C, what is the meaning of C of 3? Well, that means how much is it going to cost to make 3 scarves? What is the cost to make 3 scarves? Right, because that should be an x, right? This would be C of x. And since x is the number of scarves, what we're asking for is how much does it cost to make 3 scarves? And then part D, what's the meaning of the solution to the equation C of x equals 40? Well, that is the number of scarves that can be produced if we spend $40. So if the cost is $40, how many scarves will you make? That's that x value. If the cost, C of x, is $40, how many scarves can we make out of that $40? All right, number 8, perform the instructions for the following programming code as if you were a computer and your paper were the computer screen. Okay, I can see that x is going to be an integer. I see the function of x is 2x plus 1. I see we're going to start a set called G. So we're going to make ourselves a set here. And all x is going to be from -3 to 2 integers. So my x values are going to be -3. Let me make myself a table so I can keep track of these. Right, my x values are going to be -3, -2, -1, 0, 1, and 2. And I'm going to add to the set the ordered pairs that are produced. And then I'm going to plot them on, I'm going to plot G onto the coordinate plane. So, a lot to do. Let's do this one at a time. Let's first plug in a -3 into our function. Remember, our function is f of x is equal to 2 times x plus 1. So if x is a -3, this would be 2 times -3 is -6, and a positive 1 would be a -5. So that's our function if x is a -3. If x is a -2, well, I plug that into my x value. 2 times -2 is -4, and a positive 1 is -3. Put a 1 in there, I get -2 and a positive 1. That's a -1. And it looks like we're just adding 2 every time. Let's do one more. Put a 0 in. 2 times 0 is 0. 0 plus 1 is 1. Yeah, we're just adding 2. So that's a 3 and that's 5. So there's all of our ordered pairs, right? We can just say, well, this is an ordered pair, so on. And then we just have to plot. So the first ordered pair is left 3 down 5. That's right there. And then left 2 down 3 would be right there. Left 1 down 1. Don't go left or right, but go up 1. That one's there. 1 to the right, 3 up. And lastly would be 2 to the right, 5 up. And we're not drawing a line because they're integers. So they can only be integer inputs. And that means we don't have any data in between the dots. So just dots. Number 9, same thing. This time we're just going to print true or false. So I'm going to show that in my table, x, f of x, input, output. X is going to be an integer again. It's all integers from 2 to 7, so 2, 3, 4, 5, 6, 7. And if x plus 2 equals 7, then I'm going to print true. If not, I'm going to print false. And then I'm going to do that for every x. So here it is. Let's see. We've got, if x is 2, we get 2 plus 2 is 4. Does 4 equal 7? No, that's a false. If x is 3, that's 3 plus 2 equals 5. Does 5 equal 7? No, false. Let's put a 4 in. 6 equals 7. False. Put a 5 in. 7 equals 7. True, that's our only one. 6 plus 2 would be 8. False. 7 plus 2 would be 9. False. So that's the printout. False, 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 true, false, false. Number 10. Let f of x equal negative 1/2 x plus 2 for x in the domain where, remember, start at the variable, where x is greater than or equal to 0 and less than or equal to 4. So what are those points? Well, let's make a table. Well, x would be, 0 would be the smallest one. And we can go all the way from 0 to 4. So 0, 1, 2, 3, 4. And then f of x is going to be whatever happens when we plug in an x into that function. So we've got some calculating to do. A negative 1/2 times 0 is 0, and 0 plus 2 is 2, so there's my first function of x. When x is 0, the function of x is 2. And we can continue and put a 1 in, so a negative 1/2 times 1 is a negative 1/2, and a positive 2 would be a positive 1.5. Put a 2 in, we get negative 1/2 times 2, that's a negative 1. A negative 1 and a positive 2 is a positive 1. And I see a pattern. Looks like we're just taking half away every time. So this is going to be a 0.5, and this is going to be a 0. All right, and now that we have that, we can sketch the graph. And remember, f of x is our y value. If we were to make these ordered pairs, I would have 0, 2, where x is, the 0 is my x value, and the 2 is my y value. So f of x is y, just allows us to plot it on the coordinate plane. And so we get 0, 2, and 1, 1.5 is about right there. 2, 1 would be there. A 3.5 would be here, and a 4, 0 is there. And then the question is, do we draw the line? Well, it doesn't say anything about it being integers in our domain, right? It just says greater than or equal to 0, less than or equal to 7. So that means all real numbers, and we are going to have a line that goes all through all those points. All right, moving on. Number 11, use the points P1, which is 0, 4, and P2, which is 4, 12. Are there values of m and b such that the graph of the linear function described by f of x equals mx plus b contains those 2 points? If so, write the function. If not, explain why they don't exist. Well, let's start with f of x is equal to the slope times x plus the y-intercept. And I can recognize here that the y-intercept is the y value when x is 0. So I know right away that that's my b value. I can plug that in right away. I can also plug in an x. That 4 is an x value. Let me do this. That 4 is an x value. And the 12 is a y value. Oh my goodness. There we go. So I can plug something in for an x value, a y value. Remember, f of x is y. I can plug something in for an x value, and I can plug something in for the y-intercept. And that's going to leave me with only the slope to calculate. So that's what I'm going to do. My y value is a 12. I don't know slope, but my x value is a 4, and my y-intercept is also a 4. So now I can solve. Subtract 4. We get 8 is equal to 4m. Divide by 4. And we get m equals 8 divided by 4 is 4. So the slope is 4, and the y-intercept is 4. So when I write my function, it's going to be the function of x is equal to 4x plus the y-intercept 4. F of x equals 4x plus 4 is our linear equation. All right. Last one is our hold on. I feel like I did something weird. Yeah. 8 divided by 4 is not 4. You're probably like, Mr. Schenkel, don't be an idiot. It's 2. So, yes, sorry about that. Mistakes. They get us all. Should be f of x equals 2x plus 4. There we go. All right, last one is the exponential. And remember, this is going to be g of x is equal to a times b to the x value, to the power of x. Remember, a is our first term, and our first term is defined by our y-intercept. When x is 0, what is y? Well, it's 2. So our a value, that's our a value, 2. Now, the b value is our common ratio. I don't know what that is, but I do know an x and a function of x. And that's going to be provided by this ordered pair, which is, this is a -2 x value, and the y value is a 0.5. It's right here. This would be 1. Halfway in between would be a 0.5. So that's 2 comma -2 comma 0.5. X value, g of x value. Okay, so now I can plug in what I know. And my g of x value is a 0.5. My a is a 2. I don't know the b, but my x value is a -2. So I have 0.5 equals 2 times b to the -2. And then from our little reminder of exponents, we can't have a negative exponent, so we have to say b to the -2 is the same as 1 over b squared. Right? The only way we get rid of that negative exponent is to consider the reciprocal. And once we've done that, then we have another problem, and that is that our exponent, our variable, is in the denominator. That's not good. So we clear that out by multiplying by b squared. That's going to allow those to cancel. And remember, we have to balance the equation, so I'm going to multiply by b squared over here. So then when that happens, I get 0.5 times b squared is equal to, well, all I have left here is 2 times 1 is 2. And now we can go about the business of isolating the b. Divide by 0.5, divide by 0.5. That's going to be b squared is equal to 4. And then to isolate, we just take the square root. And we get b equals the square root of 4, which is 2. And now I can write my function g of x is equal to my first term, 2, times the common ratio, 2 to the x power. And that is the function for that exponential function. Okay, that's it. Hope that helps. Study well. Good luck on the test tomorrow.